Okay, we are live. Let's wait for the audio and see what we got. I'm waiting for the audio. And wait, the audio. Where's the audio? Oh, this is the audio? Okay. Okay. Sounds okay. Sounds pretty good. One, two, three. Okay. So today I'm going to do a review of a channel by the name of Very. It's actually Veritasium. Veritasium, which is French or Latin for the truth, truthfulness. So already we have a problem with this guy just because of his name. He has 15.8 billion subscribers, which is more than the population of the universe. But that's fine. Anyway, so this guy, as far as I know, he is like a science. I think he studied. He has a PhD in science in teaching science. But I think he knows his stuff in general, but in this video, I just have a lot of comments. So let's start watching and I'll tell you what I think. All right, so let's begin.
You can never see anything enter a black hole.
That's nonsense. So I don't know why he begins this video with that claim, because later on he's going to say that actually it's not so, but then later he's going to say yes it is so. So I don't know what he believes after watching this video, more or less multiple times. I've watched this video and other people review this video. At this point, I don't know what he thinks, and I don't know what scientists think at this point. I honestly don't know, and I don't really care at this point because I've come to the conclusion that everybody's really confused on the fundamentals of black holes, where I'm not confused. So I don't know. I don't. I don't know what to say. So everybody believes the story that he is going to tell is what I think everyone believes. Any astrophysicist that teaches on YouTube, that has lectures on YouTube that I've seen, they all believe this. So I honestly don't know. I don't know what to, I don't know what to say. But it's nonsense. That statement, that claim that um, you're not going to see something falling into a black hole is complete nonsense. A black hole used to be a star. Most black holes started out life as a star. It's not necessarily so. They could have, I mean, there's other ways to create black holes. Theoretically, you can pile on rocks on this planet until this planet ultimately collapses into a black hole without becoming a star. And and there's other ways, and maybe I'll discuss it even during this video. I don't know, but there's other ways. There's you can use sound waves, a sound wave, to create an actual black hole, not just a simulation. Because black holes, what I discovered in my thought experiments, black holes are created by sound waves. But I don't want to get ahead of myself. All right, so this is nonsense because, so let's say a star it collapsed into a black hole. All right, so we were looking at it as it collapsed, and we saw it collapsing in front of our eyes. I mean, the explosion would hide if we were very close. The explosion would hide, but that's probably just in the visible range of light. If we would use maybe radio waves or other electromagnetic wave frequencies, I think, or neutrinos. There's other ways we can see through the explosion. So, and if we would see through the explosion, we would see the star, at least the core of the star, which is what we that's the center of the star. We would see it collapsing. There's no reason. I'm trying to think. I mean, why would it be not so? I mean, a black hole theoretically just means that at the very center, let's say, let's simplify it, at the very center of the black hole, the centermost particle was crushed and collapsed. It's, let's say it's a neutron, and this neutron was not strong enough to hold up the pressure of the star. This is not so, but let's pretend it is. At this point, the neutron is crushed. The and and that's it. I mean, once it's crushed, it breaks. Um, and what's left instead of this crushed neutron at the very center of the star is is a vacuum. There's nothing there now. So it was this neutron was holding up the entire star, and now it's gone. It was crushed. So now those particles, whatever they were, protons, neutrons, that were piled on top of this centermost neutron, they have nothing to stand on. The pressure beneath their feet. One second. Let me see. Uh, somebody's visit.
Hey, bestie.
Hey,
Girl. Hey, girl.
wait. Uh, what's up? What's up, everyone? I'm reviewing a video on YouTube. Do you wanna talk about it? It's about black holes.
Uh, what video, girl? Like, what video are you watching?
I'm watching. It's called. Let me try and share it with you. Something strange. I think this is it.
Oh my god, German accent, so hot.
Oh, so it's called Something Strange Happens. Something strange
What do you
happens when you
follow?
follow Einstein's math. See, I pronounce Einstein.
Boy, what's your IQ? Like, I don't understand such stuff. Like, I wasn't good at school, you know?
Yeah,
Like,
that's basically what I'm going to explain. That this is completely nonsensical. That
wow, for real, boy?
yeah, for real. That's my philosophy.
Then
Girl,
let
do you
me
think
teach us.
Einstein was a bottom at all?
But the reason you weren't good at school is because school is not good for you. School is not good. Period.
Slay. You
School is
ate, bro.
yeah. I hate school. School is a
No, you
disaster.
ate. What's 4 plus 4? You ate.
What's for don't ask me questions in math because I go right into philosophy of math and
Okay, then what's 1 plus 1?
it's under
What's 10 plus 9, bro?
it doesn't matter. It's all undefined. It's just a language. It's whatever we decided it is. So it's just a language.
Nah, bro. I mean, bro, it is a necessity, you know? Like, yeah, like, I mean, it's a necessity, bro. I can't say much. Like, I don't know.
I don't
I
know.
guess you just have a unique point, like unique sense of perception.
No, I just thought about it because, from all the debates, I came to the realization that math is a language, and language
Of
is,
course it is.
humans use language to communicate, and specifically about our experience. So, math is just a language to communicate our experience. So,
I think it's more than that, bro.
no, it's not. It's exactly
It's more than that.
that.
It's
That's a
more than
lie.
that. Like,
That is a
no,
lie.
it's more than that. It is
What is
more than that. You
what?
just cannot, bro. Listen, listen.
Hmm.
Language is like the language we are speaking right now.
Yes.
Okay, we transfer ideas using this. Like, you speaking, me speaking. We're transferring ideas right now.
Yes.
But in mathematics, we're not
We're
trans.
making love.
We are like transferring ideas, but the level of that stuff, it's just like higher. It's higher. Like, it's just more detailed. All that stuff. Like, it's just more deeper. I'm not good at this stuff, but I think that this is the truth. I don't know. Maybe I'm wrong, but
Um.
math is just like, you can't just say that math is just like nothing. Math is like, it is the language of the universe. We have accomplished so much
So
by advancing in mathematics.
so you agree that the word, let's say the word number, is in English, right?
What is this supposed to mean? Like, okay, I believe that number is an English word.
Okay. You agree that the word one is a word in English, right?
Yeah, it's a word in English. What else?
You believe that the word plus is a word in English, right?
Uh huh.
So you understand that one plus one equals two is a statement in the English language,
All right.
and
It's
you
a fact and a statement. Okay.
okay, and the English language evolved side by side with the evolution of humans, right?
Truth.
So the number one is a word that evolved with humans.
Mm-hmm.
So one cannot be accurate to to an absolute value. One is just a word that is designed to transfer
But.
some
Mm-hmm.
psychological state of mind from me to you. When I
Mm-hmm.
think of one, I have something in my
Mm-hmm.
mind, some obscure notion, and I want to share it with you. That's the word.
Okay, that is true. That is true. But the number one, it is supposed to represent something.
Just
It
like
is
everything,
supposed to represent unity.
just like the word sky. The sky is blue. There's no difference between the word sky and blue and is and the. These are just words that represent states of mind, some
I
notions.
think you must. I think you should stop studying that much. Like, this is generally like, this is generally harming you. Like, uh, I don't know. If you just keep going on like this, you might fall into depression. You might just feel like life has no meaning or
Schizo.
something. I'm not joking,
How
man.
is
I
that?
swear to God.
Wait,
And
why?
not even. I don't like. If I don't care if you're an atheist or something. Like, I respect you, all that stuff. But bro, you gotta stop thinking too deep. Like,
What do you
Yeah,
mean?
man. The only thing you should take deep is dicks, man, in your ass.
boy, shut your bum ass up.
Why should
Well, I
I?
ain't sure my ass up. You make me sure, boy.
Why should I avoid thinking? I mean,
Because it can lead to depression, and it can lead to severe levels of, what do you say?
Schizophrenia.
Uh, what is it?
Schizophrenia.
Pessimism? Pessimism is, what is it? I cannot pronounce. I'm stupid.
Schizophrenia, man. Spell spin one.
Like, there's a limit to everything you should. But okay, if you want to do it, but I'm just, I don't know, man. Like,
Listen, if your girl cheats on you, you can't fucking use maths on that shit. You're just gonna be like, Oh fuck, she cheated. Boom, that's finished. You're not gonna be like, why did she cheat? What time did she cheat at? What did she eat before cheating? Did she clean her ass before cheating? Some shit like that. Too
Okay,
much
that is
thinking, man.
very educational. Very
Anyway,
educational of you.
that's irrelevant. Um, well, first of all, I don't know how to stop thinking because I think about these things whether I want.
Start appreciating life more. Okay,
What?
like listen to me, listen to me. What is your age? I know this is
It's
coming out
under
of
a
nowhere, but
thousand.
come on, man, you gotta
He's
understand.
22, man.
I
You're
don't
22
share.
or something.
I don't share my age.
What is wrong with sharing your age? It's just a number. Like
Yeah, but we're not
in
trying to
this
groom you,
conversation,
bro.
like for us, I know you're an adult.
Anyway, I don't share my age, so you're gonna have to do it.
Okay,
We're not trying to groom you, bro.
I'm going to assume like that you're either a young
15.
adult or an adult. But
I'm an old
I
man.
don't know, man. Okay, you're an old man,
Hmm.
but I don't know, man. The way you think is just too extreme. Like you shouldn't be proud of this stuff. Like you saying that the word one has the same meaning as sky, blue. Okay, I agree with you. I agree with you. That is true.
Hmm.
But that doesn't makes it like meaningless. You portray it as if it is a meaningless thing. You portray maths as if it's just an ordinary thing. It's just trash. It's just bullshit. No, it ain't like that.
No, I actually never said
You
any.
imply, you imply in a way or another. Like the whole title that Einstein's math is like not like you imply that it's bullshit.
No, no, no. I'm reviewing someone's video. That's not. I'm just reviewing someone else's video. I'm reviewing Veritasium's video. But I never said anything negative about anything. I'm just saying words are just social constructs.
Brother, we are 10 steps ahead. We already warning you and shit.
What?
Listen, listen. Before you do something, yeah?
Hmm.
Once you there's gonna be an oracle, which is gonna tell you if you do this too much, you're gonna fuck up yourself, right? There's a
I don't.
consequence, right?
I don't. I don't care what people say. I care for the truth.
Okay, what is the truth?
Exactly what I told you.
You don't know the truth.
Then you're welcome. I told you what I feel the truth is. You're welcome to tell me if you feel I'm wrong. We can have
But you feel like the truth. Is it really the truth, or is it something that you want to be truth?
I don't know. That's how I feel.
Now, no matter how much you think about it, you're not gonna fucking figure it out. That's why there was a guy called Albert Camus, and he came with the fucking idea of absurdity. It's absurdism. It's a fucking philosophy. You're like, okay, universe might have a god, might have no meaning, but who cares? I'm just gonna dance.
No, that's not how I feel towards the universe. I'm very curious about the universe. And
How do you feel about the universe? Are you sexually attracted? Is it platonic? Do you believe there's a god? How do you feel about god
I'm
girls?
I'm curious
Nigga,
about in reference to mathematics, I'm very curious. I used to be very curious as to the nature of math and logic. And I realized that math and logic are no different than any other language.
so
Yes.
what is it that makes it so demoralizing? Like it's what is it that makes it so worthless? You imply it as if it is very worthless. Okay, it's a language. True. It's a language of the universe. It's a language of order.
No, it's not.
Ah.
It's not the language of the
We
universe.
use math to
It's not.
understand the universe. It's
Math is not
Mhm.
the language of the universe more than English is the language of the universe.
No, that is the difference. There
No,
is a difference.
no,
English is
no.
the language of the earth. We are earth beings.
You could
English,
you could
without
say
English, there is no maths.
you could
Let me
say
explain to you like this.
you could say that
Uh huh.
math is a language that is oriented towards like counting things, stuff like that. Like no, it's oriented towards
Of course. But that is a universal thing as well. You know,
no.
like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is not only an earthly thing, that's a universal thing. Like there are one planet, two planets, there are trillions of planets. I don't know how many planets are there. But speaking English, how are you? All that stuff, that's only an earthly thing. We only we talk to each other like this.
You
The
don't
universe doesn't
know.
talk to
You
us like
don't
this.
know. You don't know how far the concept of numbers extends. You were born into a
Listen, if maths was so important, I'll tell you one thing: the Bible would be full of numbers, not words.
the Bible is I told you I don't care what anyone says. I care for the truth. So using evidence that somebody wrote, I don't care for it. I only care for
Brother, it's all meaningless. It's all meaningless. There is no truth. The truth is what someone made up for to be the truth.
no. No, the truth is how I feel is the truth. I don't care what anyone says.
Listen, you're speaking English right now, right? You decided to be English.
Hmm? No one decided.
If you're speaking exactly, it became worldwide. Why was it worldwide? Why is it a common language? Why is it necessary to learn English?
That's
Because some
Darwinism.
fucking British retard, no, because some fucking retard basically conquered it, and then another retard came and conquered the name of the British Empire, and eventually the British Empire fucking helped in World War II and some shit, and then America came, and now English is the world's first language. What if it was fucking Arabic? We'd all be blowing up right now,
Yeah, it's the
right? So
same.
obviously someone else set up the truth for you.
Yeah, it's the same as, this is just
There is no
Darwinism.
truth, only opinions.
Exactly. Well, my opinion is the truth. If I feel something is the truth, then that
Okay,
is.
opinion without power is
I
not
don't
a powerful
care.
opinion.
I don't care. I don't care for power. I care for discovering what for me is the truth.
Okay, how do you feel about getting pegged, man?
Oh my
I
god.
don't care
Bro,
for
he's like
that
a
in this
I'm sorry.
discussion. I'm busy making a video. If you have any further questions, I'll answer. Otherwise, I'm busy. So it's up to you what you want to do.
Damn man, I don't want to interrupt you, man. Like
That's okay. Uh, thus far, it was a good discussion. I enjoyed it. But if we're done, then I'll continue making my video.
Be sure to, man. No worries.
What?
hey man,
No worries, no worries. Amen.
All right. See you
like
later.
yeah, good luck
Later,
with that
boy.
stuff, bro.
Yeah.
Respect.
Yeah. Thank you. Thank you. All right. So let's continue. Let me see. We are sharing the Veritasium tab. Let me just see if I have messages. Okay, that's good. So, anyone, no one watching. Okay, let's share this tab. All right. So, we are continuing. Anyway, so I don't see a problem if we see a friend falling into a black hole. The way I see it, we're just going to see them falling forever falling. It's very similar to if I see someone except right we can even prove it in the following way. Let's say that I am alone with my friend in the universe and there is a black hole and my friend is falling into the black hole. How would I know that my friend is falling into the black hole? Right? If I am alone in the universe with my friend and he is falling into the black hole, how would I know? All I see is that he is accelerating away from me. Now, let's say I'm falling into the black hole and he's not. again, how would I know that one of us is falling into the black hole? All we know is that we're accelerating away from each other, and this acceleration keeps growing. That's all we know, right? The universe is completely dark. All we see, let's say, is just each other. We have each one has a spacesuit with some lighting, so we see each other. But I see my friend accelerating away from me. So I'm thinking, what could it be? I don't know. It could be that he's falling into a black hole. It could be that I'm falling into a black hole. It could be we're both falling into black holes, to separate black holes. I'm falling backward, let's say to the right, and he's falling to the left. Let's say I'm on the right and he's on the left, and there's a black hole to my right and there's a black hole to his left. So it could be that I'm falling into the black hole on the right and he's falling into the black hole on the left, and we would still just see each other accelerating away from each other forever. And this should never ever change. We're just going to see each other accelerating faster and faster. The acceleration is going to increase forever, and the speed is going to increase forever that we're moving, drifting away from each other. But we're not going to know what's going on because everything is completely dark. We wouldn't know that we're falling into a black hole. And this would never change. This would be forever. Forever and ever, we would see each other falling or accelerating away. That's the way I see it. I don't see. I'm trying to think what can happen, what can change this experience, and nothing comes to mind. All right, so let's continue listening.
Imagine you
Let's
trap your nemesis in a
go
rocket ship.
again.
Enter a black. You can never see anything enter a black hole. Imagine you trap your nemesis in a rocket.
So Veritasium just made a statement. You can never see anything falling into a black hole.
You can never see anything enter a black hole.
Enter. What does it mean? Enter. He makes it in his video.
You
It looks
can
like
never see anything enter.
it looks like the black hole is not a black hole. It looks like a ball of mud, a ball of black feathers that you can enter the black hole. This is nonsense. This is utter nonsense. Why would you think this way? I don't understand this.
A black hole. Imagine you trap your nemesis in a rocket ship and blast him off towards a black hole. He looks back at you, shaking his fist at a constant rate. As he zooms in, gravity gets stronger,
What do you mean as he zooms in?
so you'd expect him to speed up. But that is not what you see.
That makes no sense. Right? That statement makes no sense. We expect the nemesis to accelerate the acceleration. His acceleration should be accelerating forever. This is, by the way, the same as if he would be falling into a planet or a neutron star or any source of gravity or energy. As you get closer, the force, the gravitational field is stronger. Therefore, the acceleration that I am seeing is greater, or the speed that I'm measuring. Right? Let's say I can only measure the distance to him because he doesn't feel anything. Let's say his engines are off, so he's falling into the black hole, and his engines are off. Let's say, and I can see him accelerating, and right. I can see all I can do is measure the distance. Through the distance, I can measure the speed, and from the speed, I can measure the acceleration, and from the acceleration, I can see that the acceleration is increasing. And this I can do just by measuring distance, like with a laser and a mirror. let's say he has a mirror on the ship. I just fire the laser. The laser bounces back. I know the distance. From that, I can figure out the velocity. I see the velocity keeps increasing. I plot from the velocity, I can plot the acceleration. From the acceleration, I can see that the acceleration is increasing. And that's it. And that acceleration, I think, is a constant. I think it's the acceleration of the acceleration, I think, is a constant. The change of acceleration, I think, is a constant. If I right, yeah, I think so. I don't know. It doesn't matter. It's he's falling, just like just like anyone is falling. When we fall, it's not only that we're accelerating towards the earth, but because we're getting closer to the earth as we fall, then our acceleration is increasing because we're getting closer to the earth, far away from the earth. The pull of the gravity of the earth is lower than when we're close to the earth. Okay, so we're watching him. So as he is moving faster and faster relative to us, we see his fist. He's shaking his fist slower and slower. We see his clock ticking slower and slower. And by the way, vice versa, he sees our clock ticking slower and slower. There's no difference. We see each other slower and slower, and we cannot tell who is actually falling. Let's say again, we don't see, there's no stars, so we don't know who's falling. All we see is that we're accelerating away from each other, and we don't know why. So because of that argument, I can deduce that it's a symmetrical situation, and I see his clock ticking slower, he sees my clock ticking slower, but I must see him moving faster and faster. Otherwise, why would I see his clock ticking slower and slower? If he's slowing down, right? Did he just say that he's slowing down?
Stronger, so you would expect him to speed up. But that is not what you see. Instead, the rocket ship appears to be slowing down.
If the rocket ship appears to be slowing down, then his clock should tick as fast as my clock. That is special relativity. It's special, right? And by the way, he is in an inertial frame. No, he's not. According to me, he's not in an inertial frame. I know that he is accelerating. But I don't know this. If we're both in the dark, I don't know who is accelerating. So I don't know who's going to be seeing the other's clock slowing down. So I think we're going to just see each other's, because of this line of thinking, because special and general relativity are just based on thought experiments, incredibly enough. So we should be able to predict the experiment that we're discussing just from a thought experiment. This is absolutely incredible. The power of special and general relativity are mind boggling. All right. So so there's no right. So let's assume the universe is dark. So we don't know who is accelerating. We just don't know. We cannot know. And because of that, it must be that all we have is we see each other at any instant. I feel inertial. I feel inertial, meaning I feel no force is acting on me. I don't feel like I'm accelerating, so I assume I'm not accelerating. I assume I'm inertial. But he, to me, is not inertial. Wait a minute. I think that if he's accelerating, then just because of acceleration, his clock should be ticking slower. Just because I'm assuming he is accelerating. Because I'm assuming he's not inertial, his clock should speed up. Slow down. Sorry. His clock, his clock should slow down because he's moving faster. I mean, just because he's moving faster, I should see his clock moving slower. And just because I hope I was saying clock slower. And just because and if I assume that he is accelerating, I don't think I even need to think about his acceleration. Just the fact that I see him moving faster and faster, then due to special relativity, his clock should be ticking slower and slower. Okay, but Veritasium says that his spaceship should be moving slower and slower. He says this with no explanation. He just asserts it. Now, I'm saying it because that's the experiment. I mean, he's falling into. All right, you would agree that if this wasn't a black hole, if this was a normal planet, you'd agree that he would be accelerating and accelerating until he hits the planet. So why would a black hole be any different? A black hole, you could say, is just a planet that you squish so hard it became very, very, very small, and then you crushed it beyond the ability of the neutrons to hold up, and it just collapsed. Fine. That's it. That's the difference. The difference is that the material was crushed beyond its ability to hold up against the forces, so it's crushed. We don't see it. But the mass is still there. And now instead of right, we crushed it and crushed it and crushed it. Like if we crush Earth, I think to they say, I don't know, a grain of salt or something, or maybe a bean, a chickpea or whatever, like a marble. At that point, the neutrons are already going to decay and they're going to get crushed, and that's it. The that marble after at that pressure will collapse. Now, collapse just means it falls into its own center forever. So now there is a hole there, and the gravity is still there. So there's no reason to expect anything to change. Anything I drop into that black hole should continue falling forever. Why should it ever slow? I just don't understand. It should accelerate forever. Why should it ever slow down? There's no reason to say it should slow down. Why would you say this? And this is obviously not Veritasium. Veritasium is just repeating the words of the consensus of the scientific community. Scientific community, they all believe this nonsensical idea. Okay, let's continue.
Not only that, he also appears to be shaking his fist slower and slower.
This is a complete contradiction. You cannot say both of these things. There's no way you can say both of these things. If he's slowing down relative to you, then he should not be slowing down his fist. His clocks, his internal clocks, should not change their rate if he is slowing down. I mean, obviously, that is obviously a contradiction. That's a contradiction. If you see him slowing down, then you cannot see his clocks slowing down. His clock should be basically the same as yours. This makes no sense. You can never say this. This is a violation of special relativity. Just special, good old special relativity. It says that as objects move faster and faster, their internal clocks must tick slower and slower. That's just because we assume the speed of light is constant to all inertial observers. So I'm looking at this guy. Let's imagine I can see the photons, the light in his internal molecules. Let's say I could see the very light inside his every atom. Then that light, and this I think comes from Einstein. He thought about this thought experiment. So he said there's two mirrors. Let's assume that this guy has two mirrors and a photon bouncing between these two mirrors, light bouncing between these two mirrors. So as someone is traveling faster and faster, because the speed of light is constant relative to me as an inertial observer, then that light must be bouncing slower and slower relative to me between the two mirrors, because the light needs to cover more and more distance as it's traveling faster and faster relative to me. So things that move faster relative to me must, and their clocks must tick slower. That's Einstein's special relativity. So the nemesis must be moving faster, close to the speed of light, in order for me to see his internal clocks slowing down. Or he must be moving relative to me. If you're saying he stops relative to me, then his internal clocks should be ticking at the same rate as my internal clocks. So this makes no sense. 0 cents. Okay, I mean, absolute nonsense.
That's because, from your perspective, his time is slowing down.
What do you mean? Why? Why is his time slowing down? So if he landed on the surface, let's say the black hole actually had a surface and he landed on the surface, so you could say that because of general relativity, because of what they call the curvature of space, because space, it's not really space that's curved, it's really space. The space flows, because space flows into the black hole. So again, that forces a longer distance of travel. We can show this. We can show that again, the light bouncing between the two mirrors on the Nemesis's ship must be taking longer and longer as the gravity is stronger and stronger, assuming he's standing on the surface. So that because he's standing on the surface, now he's not inertial, now he's accelerating. So the light bends. Anyway, so but this is, he's not landing on the surface of the black hole, because the black hole has no surface. So why would he be slowing down and stopping? This makes 0 sense.
At the very instant when he should cross the event horizon,
What is an event horizon? What is an event horizon? What is this nonsense? This is another nonsensical idea. See, I am only running a thought experiment of a black hole. I don't use any mathematics, any diagrams, nothing. I just think about a black hole. A black hole does not have an event horizon. It doesn't have an event horizon. Things that fall into a black hole forever fall into a black hole. If I stand outside and I watch them falling, I will forever and ever see them falling. Period. I will forever see them falling. Forever and ever. I mean, they're going to be accelerating faster and faster. Yeah, they're going to be accelerating faster and faster, and faster and faster and faster and faster, but they can never reach the speed of light. So I'm watching them. let's say traveling at 99% the speed of light and 99.9 and 99.9999999% the speed of light, but they're never crossing the speed of light. So you could say that they're red shifted. Are they red shifted? I mean, the very speed, does speed cause a redshift? No, speed does not cause a redshift, but the acceleration might cause, because the acceleration is so high, maybe because the acceleration is so high, you'd get a redshift. But just the speed does not cause. But forget about the redshift. I mean, what Veritasium just said makes no sense. Again,
is slowing down. At the very instant when he should cross the event horizon,
that's a completely nonsensical idea. Absolute nonsense. What is this event horizon? What is it? What is it? What is this thing? Event horizon. What is it? I don't know. Uh, there's no event horizon. Things that fall into a black hole fall, forever and ever fall. Forever and ever and ever. That's it. That's the end of that. Just like anyone accelerating away from me. Forever accelerating away from me. So is he going to stop relative to me if he's forever accelerating away from me? No, I'm going to see him forever. Forever accelerating away from me. I'm going to see him forever accelerating away from me. That's it. But he's not going to reach the speed of light. I cannot observe anyone or anything traveling faster than the speed of light, obviously, because we use light to observe, or whatever we use to observe, information, according to Einstein, does not travel faster than the speed of light. So, but especially if we use light. Hmm. I'm thinking about information traveling. I never thought about this. Why? How can Einstein say that nothing can travel faster than the speed of light? I understand that I cannot perceive anything. He said that the speed of light is constant for all observers. The speed of light is very for all inertial. Okay, we're not going to talk about that now because I have not resolved relativity yet. I know very little relativity at this point. I'm still thinking about it. Okay.
the point slowing down. At the very instant when he should cross the event horizon,
This is nonsense. I mean, this is like an optical illusion. So Veritasium, the way he looks at the black hole, so what he's calling the event horizon. So what is he imagining? He's imagining that this guy is coming from the side. So I let's assume that I the my nemesis, I push them towards the black hole. So my nemesis with the ship is moving away from me towards the center of the black hole, away from me. Right? Then we all agree that forever I'm going to see my nemesis falling into the black hole. And then the question becomes, okay, what about if he comes from the right side towards the black hole? So the way the black hole works, what is this region of blackness that they show? And they say this is the event horizon. Is it? Is that the event horizon? So what happens? I mean, so according to Veritasium, if somebody travels from the right towards this black region, what am I going to see? Okay, let's think about. Okay, let's say my nemesis travels exactly towards the center, away from me. Now let's say he's not, he's just a little off. He's gonna still fall, right? A black hole is just a hole. I don't think it matters where you come from. You can just view it as any other hole, any other well. It's just a hole. It's confusing because it's a three-dimensional hole. But as he comes, I would say, as he moves from the right towards the black hole, I'm going to see him. All right, let's say he's traveling exactly from right to left. So as he enters this region, he's going to start moving relative to me towards this more and more towards the center. He's going to curve towards the center of the black hole. But I will forever see him. He's not going to just poof disappear. No, there's no such thing. I will forever see him. You could say because of the acceleration, he's going to be redshifted and then black shifted, right? The redness is going to just grow more and more dark until it becomes black shifted. Fine. So he's going to become black shifted, but I'm going to see him tiny, 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 moving faster and faster away from me. And he's going to be red shifted and black shifted, but I'm going to see him falling towards the center. So if I see him coming from the right to the left, I will see him. I think, of course, I'm going to see him crossing this boundary. There's no boundary. So, what is this boundary? What is this blackness? So, this blackness is because there's nothing there, that everything already fell. That's why it's black. But anything that falls in, I see it falling and very quickly accelerating and black shifted and growing smaller and smaller and faster until it's completely black shifted. So I cannot notice it. But the reason it's black is because there's nothing there. If I keep throwing things into the black hole, things that are emitting light, I could cause the interior of the black hole to glow. There's no reason why the interior wouldn't glow. Just like if you have a well, you look down a well and it's completely dark. You use a flashlight, you try to light the well, and you still cannot see the bottom. Let's say it's a very, very deep well. It's a kilometer deep and a meter wide. Diameter is 1 meter. There's no way you're gonna with a flashlight see the bottom. Maybe with a laser beam. Anyway, so you cannot. Let's assume we cannot see the bottom. But if you throw in a torch and another torch, let's say you throw in many, many, many torches one after the other, then of course you're gonna see all the way down to the bottom. If you pour in, let's say, gasoline on fire, and as it's falling in, it's on fire, then you will see the entire interior of the well. What used to be black is now white. The reason the black hole is black is because right now there's nothing falling in. But if you throw, hey, what's up? Let me shift over to you. Trudeau. What's up, Trudeau?
Yo,
Yo,
I
I'm reviewing Veritasium's latest video about black holes. Let me show you.
I'm not gonna lie.
Mm-hmm.
I looked into your channel a little bit because the way you talk, it seems like you kind of had a lot of followers. I mean, to be honest, you don't. I mean, not that that matters. Uh, I think someday if you try and avoid topics like the one we first met, I think could be successful.
Avoid what?
Anyways,
Avoid what topic?
like the atheist equals dumb one. That was so stupid. Anyways,
The atheist stuff? You didn't like the atheist stuff?
yeah, because that was just wordplay. That had no bearing on anything. That was like your opinion on how what words. Not that it's like wrong, but it's just dumb.
So you think other than that I can be successful?
Yeah. And anyways, I was saying,
Yeah.
I saw you you did a debate in like a gimp suit.
Yeah, that's like old stuff. That's like from over a year ago, I think. 2 years ago or something.
Is that actually you?
Of course. Who else would it be?
What was the? Well, I don't understand.
Yeah, it's it doesn't really matter. I mean, who cares? Why is it important? If you don't understand, then it's not important. It's not.
Uh,
It's honestly not important.
it's different and it's unique. I'll say that. Nobody's ever done that.
Fine. I mean, I
That was a compliment. That was supposed to be that it's unique, so that's interesting.
it wasn't it wasn't my point for it to be unique. It was just
Yeah,
supposed.
that's why. Yeah, I'm asking.
Yeah.
What was your point?
The point was to invite Alex playing with fire to debate me because I was, you know, watching his channel religiously, and I felt that he's giving bad advice because he was teaching men to be dominant, and I wanted to explain to him that some men don't want to be dominant. And I'm not looking for a relationship in which I'm dominant. That's not what I'm looking for. So his teachings are only good for one particular type of men and not for other types of men. Certainly not my type. So my type is I need to find women like it's a little different than the way he finds women. When he sexualizes with women, it's as a dominant man. When I sexualize with women, it's as a I I don't want to be dominant. I want to be submissive.
Yeah,
Because if she is looking for a dominant man, then she can continue looking. I'm not interested. I am repulsed by women who enjoy dominant men. It is repugnant to me.
that's funny.
Yeah, I find such women asexual. A woman could
Yes.
be the most beautiful creature in the universe. No, I mean, anyway, it doesn't matter. I mean, it really doesn't matter.
You're very forthcoming with your
Well, I
sexual
hope.
preference.
Yeah, I hope to remain anonymous. That's that's why
Yeah.
I I'm religiously anonymous. It's not. It wouldn't be the end of the world if they blow my cover because at this point I'm an old man. I really don't care.
How old are you?
Oh, I'm very old. I'm very old.
Like older than 50?
I cannot say because I don't want to I don't want to get doxxed.
Yeah. Yeah, it's okay. Have people gotten close to doxing you before?
I mean, I know people in real life, like that woman I was with. I mean, she was my best friend, so of course she knows who I am. So some people in real life, of course, they know who I am.
Yeah.
But these are people that I trust. I trust with my
Yeah,
life.
that's fair.
Yeah. And since then, I told you, since then, I have received a bunch of times death threats. So
Yeah.
I really need to watch out. Anyway, so you reviewed my channel and you enjoyed it?
I did. I kind of grazed through a lot of the stuff. I mean, I have a kind of small attention span.
Mm-hmm. Yeah,
Um,
mm-hmm.
yeah,
Yeah, my videos are usually very long form. I don't like short form.
yeah.
Because when I watch videos, I only like long form. I hate short form. I like videos that are as long as possible. Like 5 hours videos are my favorites because then I can work. I don't need to look up videos. Like I'm most efficient when I have 5 or 8 hour shows running in the background because then I can just sit and work and listen to people's nonsense. It's terrific. So I'm making content for people who are like me. That but so you went. Did you have like? Did you find like? Could you say that you have a favorite video of all the videos that you saw?
Probably the gimp suit one. I know that's not your video, but
What do you mean it's not my video?
I didn't. Was it on your channel? I think it was on somebody else's.
Oh yeah, this was before I created my channel. This is like a couple of months before I created my channel. It's on Alex
But
Playing with Fire.
yeah, it recommended it to me when I was looking through videos. I was like, what the fuck is this? Surely this isn't the same person.
No, that's me. That's obviously me. You can tell by the voice, by the accent.
Yeah.
Yeah, that's me. There used to be other videos, but those channels got taken down. I mean, YouTube is ruthless in its, authoritarianism. So that's all that's left, which is very good because, I want minimal information. I want to be exposed minimally. And besides that, I mean, did you enjoy any of my philosophical, my debate videos?
Um, like I said, I just like looked over them and I spent maybe like 5 minutes max
I see.
looking through it.
I
Like
see.
I said, I'm 20. I have a short attention span.
I see. You sound much older because I feel that you're like you're by far wiser than a normal 20-year-old.
Yeah, this guy, this I'm sure you're familiar with a lot of people in this Discord server. Oh, what was his name? He's Swedish. He's Swedish. He's a Christian.
Hmm.
He's a white nationalist.
Oh yeah,
Um,
I've met those. Yeah, I've debated those. Yeah.
do you know the one I was talking about specifically though?
No,
Probably not. Uh, um,
I probably wouldn't even recognize if you told me his name because I usually don't
yeah,
pay attention to the name.
fair. Um, but yeah, he kept on insulting my voice, and that was like his best thing.
Yeah.
Hello,
Yeah.
Mr. Slave.
Hello, Sigma man. How are you?
Pretty good.
I'm actually in the. Oh, he came and left. That's good. Anyway, I'm gonna continue making my video on Veritasium.
Yeah.
Unless you want to talk, you want to do something, you want to have a debate,
Um.
maybe later, because maybe I'll finish my video and then I'll deep.
Yeah. Yeah. Sure. If I'm still awake.
Yeah, yeah. I also
Yeah.
need to go to sleep. You're in England?
In United States.
Where? New York?
The South, American South.
Texas?
Huh?
Texas?
No. Georgia.
Oh, I don't know anything. I don't even know where Georgia is. Is it nice there?
It's fine. I mean, it's a swamp.
It's a swamp.
Like, it's so unbelievably like it feels like you're swimming in dirty water outside. It's so like what's what I'm looking for? It's like the water or the air is so like dense with like evaporation. It's so hot. You know what I'm saying?
Humid. You're saying it's like incredible.
Humid. Yes. Yes,
Oh,
humid. There you
that's
go.
terrible.
It's
Oh,
terrible.
that
It's
is the
terrible.
worst. So why don't you move like somewhere else, like north or Texas or
Um
California?
like I'm 20
Yeah.
and the economy sucks. So I can't really do shit.
What are you
And
studying?
I'm not yet, no.
Do you know what you want to be?
Radiology, something like that.
That's good. So you should be able to move to California.
They have colleges everywhere.
No, I'm saying for life. After for life, I would move to California, I think, or Texas. But probably I would go to Silicon Valley at this point in my life.
In a couple of years, I'm actually gonna go to Finland.
Why? Why Finland?
I have a cousin who lives there.
But why Finland? What's in Finland? Like you like Finnish
My
girls?
cousin. My cousin.
I see.
My cousin. Is my mic out?
No, no, no.
Hello? Oh,
I can
okay.
hear you. I
Yeah.
can hear you. But
Sorry.
why do you care for your cousin? Don't you want to get like?
Why do you care for your cousin? He's my I mean, I don't know where you live and family values, but he's my cousin. He's a cool cousin.
So because you have a cool cousin in Finland, you're moving to Finland?
I'm not moving. I'm visiting.
Oh, okay, okay.
I
Yeah.
mean, I'd love to move to Finland. I like Finland better than it is here. I
Uh,
mean, other than the Russia threat.
yeah. But I think the quality of life in Europe in general is lower than the US. Well, we can have a discussion about that if you want.
Yeah, maybe that'll be our topic. I mean,
Yeah.
I don't know. That seems kind of. You'd have the leg up because I can tell you're European.
No, no, no. I just look up statistics. I just look up numbers. I look
Yeah.
economic metrics to see where if it's worth it to move there. That's all. I would just do the analysis, the numerical analysis. That's all. Nothing. I don't know
Why do you
anything.
hate Finland so much?
I don't hate anything so much. I just love America so much.
Have you
America
been?
is what?
Have you been?
I'm an American. I'm just traveling right now, but I'm an American. I love
You
America.
don't sound American.
I'm not born. I wasn't born, and I cannot be the
Yeah.
president. But I love
Yes.
America. I think America should conquer the planet. That would be the best thing for this planet if America just conquered it. It would be the best. That's what I would do if I would be the president. That's what I would do as a favor for the planet. Anyway, I'll DM you when I'm done, and if you want, we can talk. Or if you're sleeping, then tomorrow. All right.
Yeah, sure thing.
All right, man. Catch you later.
All right, I'll see you.
All right. See you. Bye. All right. So let's continue. Let's see how long have we been. We've been here for an hour and 8 minutes. Let's continue with the share. Let's listen.
Is slowing down. At the very instant when he should cross the event horizon,
No, that's nonsense. There's no event horizon. There's nothing to cross. As he moves into this black region, I would still see him crossing, and I would see him moving towards the center of the black hole, and he would just fall into the center of the black hole. Everything falls into the center from every direction. The question is, if he comes from the back of the black hole, would I see him? So that I think, so if he comes from the back, so because the light is bent, I would see him. That's an optical because of because. Oh wait, Oh, Mr. Blonde Thunder, what's up?
That's me.
Yeah,
No, that's just sort of my kink. Did you see that? It's like these pagan women and men dominating the Christian missionaries, you know?
that's your sexual kink?
Yeah, that's right.
Oh, so you also like dominant women?
No. I'm part. Okay, look, hold on. No, hold on. I'm not the Christian. See, let me show you other ones. Let me
Okay,
show you. Look,
but
look.
I just want to update you. I'm in the middle of recording a video, Veritasium's video about Einstein's general relativity, black holes, Schwarzschild.
Yeah, that's cool. We can talk later. Don't worry about it, man.
Okay.
Okay, cool. You have a
Yeah.
good one.
Okay.
Okay, bye.
Sigma. Yeah, I'll see you later. Sigma man, what's up, Mister?
Sorry.
Okay. All right. Let's continue. Where is? Wait, what's going on? Okay, this is it. Fine. Okay, let's continue. So if my nemesis would be approaching the black hole from behind, then we would get an optical distortion. So that's just too complicated to explain in words. So that's not important. But if I no, but the question is but would I ever see him falling into the black hole if he comes from just any direction? That's a good question. If he's coming from behind the black, if he comes from the right, I see him falling in. But what if he comes from just a little bit behind? Yeah, I think I'll always see him. If imagine somebody from behind is pouring burning gasoline or something really shiny from behind the black hole, would I see it? No, I don't think so. I don't think so. I don't. Why not? So because I'm assuming that, right? It's a strong assumption that at the very center of the black hole is a very is a higher gravity. As far as I can tell, looking at the black hole, right? So everything falls towards the center. So at the center is basically the entire mass, all the masses that fell into this black hole. At this point, it's super duper heavy. So it's a really, really heavy black hole. It's the weight of at least one big star, bigger than the sun. So so it's really heavy. So that already fell into the center. Now the question is, that fell into the center. So why am I seeing this blackness? What is causing this blackness? It's not, I don't accept this notion of an event horizon because whatever falls in, I should see forever falling in if it falls away from me towards the black hole. If it's on the right, then I'm going to see it probably falling towards right from right to left. It's going to fall, and as it falls, I'll see it accelerating towards the center, faster and faster and faster. Because at the center, but why am I seeing blackness at the center? Why am I seeing this blackness? Why is the black hole so black? What is this? What is this blackness? So this blackness is theoretically anything inside this region cannot cannot shine, but that doesn't make any sense. So they say there is one point where the gravity is so great that it's at the speed of light. The gravity is so great, it's at the speed of light. I don't know if that makes any sense. If I see an object falling on, I don't know if I have an answer to this. I didn't give it enough thought. Because I never thought what happens if my nemesis falls in from behind the black hole. And why is it black? And is it black? Is it true that it's black? So they say, I mean, so a well has walls. That's why, and light doesn't right. No, the light doesn't shine into the well. That's why it's black. A black hole is black because everything already fell in. If I throw in stuff, I could light up this region. So this region can light. Oh, didn't think about it. Forget it. Let's continue listening. I don't have answers to that for now. Let's continue listening.
The point beyond which not even light can escape.
He's saying it. The point, there's no such point. There's no such thing. What do you mean? Something falls in. What do you mean the point beyond not even light can escape? What does that mean? Something is falling in. I should be able to see it forever. There's no there's no such thing as a point beyond which light cannot escape. I cannot see that far because I'm just going to see my nemesis falling in forever. And you could argue that from his point of view, right? Because all I can witness is my nemesis falling in. The maximum speed he can attain is the speed of light. But from his point of view, well, from his point of view, he's looking at me, and I also can only attain just the speed of light. So we're both. So he cannot. He must see me forever, and I see him forever. But he sees me moving away from him faster and faster, but never reaching the speed of light. But he should see me forever. And you could say because of the acceleration, you could say that we get black shift. We get red shift and then black shift. So we stop seeing each other. Fine. But that's basically because A, it's going to be because of the distance, and B, it's just going to be the speed. If I see something moving faster and faster away, it's just going to be red shifted and black shifted. It's just moving so fast away that the light emitted just gets red shifted and black shifted. But is there like a wall? It's accelerating. No one is forcing it to accelerate. It's because it's free falling. But theoretically, I could let it fall with a tether, with a rope. And let's say it's a very, very strong rope, and let's say he has a laser beam, so he's shining it towards me. and it's very, very, very long. So he can go theoretically and forever, and I would see him forever because now he's not accelerating, so there's no redshift. The reason why everything is black shifted is because everything is falling in. But if it's not falling in, then it's not moving fast. Let's say it has engines or it's tethered to the outside. There's also the option of a rotating black hole. Let's say it's rotating, so I don't even need the black hole to rotate. Let's say something is falling in while rotating about the black hole. So this rotation, using this rotation, it can orbit. It should be able to orbit inside this black region. There's no reason, as long as I can see it, there's no reason I shouldn't be able to see it orbiting. But does it really have this black region? So, I mean, they call it a photosphere. I think they're confusing the photosphere with the event horizon. I don't think an event horizon exists. Now, you could say that the photosphere exists and the light horizon might exist, but that's fine. That's not an event horizon. Anyway, let's continue.
He and his rocket ship do not disappear. Instead, they seem to stop, frozen in time. The light from the spaceship gets dimmer and redder until it completely fades from view.
No, that's only if he accelerates. You get redshift only if he accelerates. You're saying he stopped, then it's nonsense. Of course, if he stops, there's no redshift. Redshift is just because of his acceleration. That as he is transmitting a wave of light, if he is accelerating, then that as he is waving it, he's stretching it out. What if what if he's not accelerating? What if he's just moving fast? Would you still get a redshift? If he's moving fast, oh my god, I don't want to waste your time listening to me thinking. I usually do my thinking while not recording. Anyway, it's important, but I don't have answers to these questions. So let's continue listening. Let's move back and hear this nonsense again. When I say nonsense, I think even Einstein believed this nonsense. But I don't like it that Veritasium just repeats other people without without giving credit to whoever he's quoting. I mean, he's quoting someone. He's not like me. I don't quote anyone. As you can tell, I think about everything from first principles. But he's not. He's just repeating. So at least tell us who you're getting this from.
Should cross the event horizon, the point beyond which not even light can escape.
Wait, the event horizon is the point beyond which not even forget it. We already proved that that doesn't make any sense. What is the what is that point? What is that point? Why should there be such a point? Okay, somebody visited me and left. Okay. I don't know why should there be such a point. As far as I can tell, something falls into the black hole, I can forever see it. If it's accelerating, fine, it's going to be redshifted. Let's say it has rocket engines, atomic engines. So it's able to stabilize itself inside the black hole. Why would it not be able to do that? What is the black hole? Why is it black? What's causing this blackness? Why is it black? Why is the light from behind not shining? Why can't we see it? I need to think about this. Let's continue.
He and his rocket ship do not disappear. Instead, they seem to stop, frozen in time.
That's obviously ridiculous because that's a contradiction even within special relativity. It just makes no sense. That's obviously nonsense. I mean, that's obviously nonsense. So what is this based on? This nonsense. This is completely counterintuitive. Relativity is an intuitive theory. It's a theory that comes directly out of intuition. You cannot defy intuition. You cannot tell me from intuition I derive a phenomenon that defies intuition. No, no, you cannot. You just cannot. You cannot defy intuition. In relativity, I'm not going to discuss relativity now. Anyway, or should I? I mean, special relativity is just the notion that it has no meaning to have a speed. It doesn't mean anything. If imagine I'm alone in the universe, all alone, no one else, no stars, nothing. Does it mean anything to have a speed? Does it mean anything to be stationary? Of course not. That's special relativity. That's half of it. And the other half is that the speed of light is constant to all inertial observers. The question is, where does that come from? I don't know. I think it maybe comes from Maxwell. Let's continue.
The light from the spaceship gets dimmer and redder until it completely fades from view. This is how any object
Over time? How much time? I mean, what he just sits there and what lights out slowly, fast, instantaneously. What is this?
would look crossing the event horizon. Light
So he's crossing the event horizon slowly?
This is how any object would look crossing the event horizon.
That doesn't make any sense. So we would see him crossing the event horizon slowly? What does that mean?
Light is still coming from the point where he crossed, it's just too redshifted to see.
Why is it redshifted? Why is it redshifted? Why? Why is it redshifted? What is this nonsense?
But if you could see that light, then in theory you would see everything that has ever fallen into the black hole frozen on its horizon.
Why is it frozen? Why is it not falling in forever? It's just falling in forever, that's all. It's really very simple. Everything is still falling in. It's completely red shifted. It's black shifted. And this is he has here D red shifter 3000. So he's D red shifting everything and then he's seeing everything that fell. But he says, yeah, it's this is like the ancient ones, how they believed that all the heavenly bodies are on a glass or on glass spheres that surround the earth. This is what they believed, that the moon is glued onto a glass sphere around the earth, and so is the sun and all the heavenly bodies. So he believes that things that fall into the black hole are just they just get pasted on this glass sphere that is the event horizon. By the way, I'm running tests on my laptop, so it's pretty good. It's almost up to 1,000. So it's going to run 1,000 tests, and we're up to 870, 880 tests, and all of them passed. That's good. So that's obviously nonsensical. According to me, it's falling forever. And using the D redshifter, yeah, you would see everything that ever fell in. They're always and forever falling in.
You would see everything that has ever fallen into the black hole frozen on its horizon, including the star that formed it. But in practice, photons are emitted at discrete intervals.
That's irrelevant. You don't need to say photons and discrete. Light gets redshifted. The frequency. It's actually because it's a wave. It's not because of what did he say?
Star that formed
Why does he say such nonsense without foundation? At least tell us where you're getting things from.
it. But in
At least have sources. Do you have sources? Does he have sources? References. But he doesn't say during the video every sentence what the source is. Is there a script? There's no script. Einstein was wrong about black holes. What else? Use code Veritasium. All right. A massive thank you to Professor Geraint Aflouis and Professor Juan Modla for their expertise and help with this video. Okay, but what? So you got everything from them? They're your ground truth. A huge thank you to those who helped us understand this complicated topic, Dr. Whatever, Brahma, Professor Carlo Rovell, Dr. Whatever, Professor Martin Boa. Oh my God, my eyes. With Professor Hamilton, Frederick Nyberg Broda. Alessandro Russell from Science Click for spectacular simulation feedback. Science Click is very good. So Science Click watched this video and okayed it, which is okay. I mean, I don't know, whatever. I disagree with this video. An excellent book on this topic, inspiration, is Cox, Bryan, and Farshaw, Black Holes, the key to understanding the universe. So from there you got so that's what they have to say. Yeah, this is the scientific consensus. This is like every other consensus. Makes no sense. All right, let's continue.
practice, photons
So he got this idea from all these people. Terrible.
are emitted at discrete intervals, so there will be a last photon emitted outside the horizon.
You don't need that. You just say that it's redshifted because let's see, is it enough for it because of the speed it's redshifted? My intuition is that speed is enough to cause it to be redshifted. If something is moving away from me, is it redshifted because it's moving away from me? I think so. My intuition is that it's because of the speed. The speed is enough to redshift. I think the acceleration also maybe redshifts, but certainly the speed should be enough. So that's it. That's all you need. It's just a wave. And this is the redshift is basically the ambulance effect. What do you call it? Forgot the name of the ambulance effect. That the ambulance moving towards you sounds one way. When it's moving away from you, it sounds different. So as it's falling in faster and faster, it gets darker and darker until as it reaches the speed of light, it becomes completely dark. As it falls in, it never reaches the speed of light. So at the center, I can see everything very, very close to the speed of light. And so it's very, very dark. It's almost completely dark, but never completely dark and never completely at the speed of light.
And therefore these images will fade after some time. This is
What do you mean they would fade after some time? Why would they fade after some time? According to you, why would they fade after some time? Why would they fade? They're still there. Why are they redshifted? As a function of time? That doesn't make any sense.
just one of the strange results that comes out of the general theory of relativity, our current best theory of gravity.
Okay. So general relativity is our current best theory. Shut up, Siri. It's our best theory of gravity. Uh, yeah, yeah, yeah. It's a yeah. But what do you mean best? What's the alternative? Why do you say best? Do you have an alternative? What's the alternative? How can you say best? That doesn't make any sense. There's no alternative to general relativity. General relativity talks about the flow of space. Space becomes this ether that flows into a gravity well, and the light that travels on this ether bends because, well, we'll get to it in a second. Anyway, all right, so let's hear this again. This more, everything he says is nonsense. Everything he says is nonsense. Like he cannot say a sentence that is not nonsense.
Therefore, these images will fade after some time.
No, no, they wouldn't. According to you, there's no reason for them to fade.
This is just one of the strange results that comes out.
Okay, so this is a strange. So you agree that it's a strange result. That's not good. General, anything that comes out of general relativity cannot be strange. It's a theory of intuition. It's based on the equivalence principle, which is just intuition, that it feels the same to fall as it does. Sorry, that it feels the same to be in an accelerating rocket as it does to be on the surface of the Earth. If you're in an elevator, you don't know why, you don't know what's going on. Are you in an elevator on Earth, or are you in a rocket ship accelerating accelerating? So that's it. That's what general relativity is based on. That, okay, whatever. So it comes out again.
Will fade after some time. This is just one of the strange results that comes out of the general theory of relativity, our current best theory of gravity.
Okay, whatever.
The first solution of Einstein's equations predicted not only black holes, but also their opposite, white holes. It also implied the existence of parallel universes.
It implied white holes. So I'm trying to think from intuition. Would I predict a white hole from general relativity? Why would I predict a white hole from general relativity? Why would it come out? Why would a white hole come out of general? A black hole, we know, is because of gravity. Why would we get a white hole? So a white hole, I was thinking, is what it feels like to be inside the black hole as it forms. I said maybe if I'm inside the very center, let's assume that I'm inside the very center of the star as it collapses, as it's crushed. So let's say I'm inside that neutron at the very center of the star, and it's crushed. I'm a tiny creature. I'm inside that that, and it's crushed. Now what? What am I experiencing now? So I'm experiencing, obviously, right? Until now there was incredible pressure on this neutron, but now the neutron collapsed. So there's no more pressure. So there's a vacuum. And at the center of a star, just like at the center of any symmetric object, there is no gravity. At the center of Earth, there's no gravity. If you drop something at the center of Earth, it doesn't go anywhere. So there is no gravity. There's only pressure. Okay? And pressure. Okay, but we lost the pressure. At the center of Earth, there is pressure, but at the center of a star, right after the central neutron collapsed, there's no pressure. We lost the pressure, and there is no gravity. So I was thinking, oh, that's a black hole. Right there is a black hole. That space where there was a neutron and it got crushed at that space now, that's a black hole. Why is it a black hole? Can light not come out of that? Why not? It's just a vacuum. Why can light not come out of that? It's a vacuum with zero gravity. It's not even black. I don't know. I don't know. I don't know if I would say that. So I was thinking maybe if I'm inside, what about it? What if I'm inside? Is time ticking differently? No. No, time at the very center of the earth right now is it is the neutron at the very center of the earth, is it moving internally slower because of time dilation, because of the high pressure? I mean, the high pressure is supposed to be like high energy, and it's supposed to bend space. So it's supposed to cause a gravitational well. So anything outside of that neutron should experience a gravitational pull because of the high energy. Because it's like that neutron, because it's under so much pressure, actually weighs a lot. Because it's under so much pressure, I think we can measure its mass. Should its mass increase? Theoretically, yeah. Because we can see light bend around it. That is literally the equations of general relativity. So, but inside the neutron, nothing has changed. I don't see a white hole. I don't see it.
But also their opposite, white holes. It also implied the existence of parallel universes.
No. No. These are, we're going to get to it. These are just side effects or artifacts of mapping techniques, of coordinate systems. I don't care about your coordinate system. I care about the intuition of of a black hole, just as I have discussed it thus far. I don't care about your math.
and even possibly a way to travel between them. This is a video about the real science of black holes, white.
No, no, it's not. This is not. I don't see how this is science. I don't see how this is science. Sir, I don't know why you call this the real science. Well, is there fake science? I don't know. Well, I don't know what you mean by real science. It's either science or it's not science. I don't think I wouldn't call this science. Science is what I'm doing right now. That's science. That's science. What you're doing is you're repeating what other people have told you, which you claim makes no sense. That's not science. Science has to make sense. Science is theorizing about phenomenon. Theorizing, the act of theorizing is building simple models that mimic reality and gives you predictive powers. You're doing nothing like that. You're not theorizing. Where is the theory? What is your theory? What is even the phenomenon that you're investigating, that you noticed? So you could say, oh, we noticed black holes. Okay, fine. The question is, what is the phenomenon that, in order for this to be science, so what you could say here is science is that we're doing the predictive part of the theory, but science is you first start with a phenomenon. You would have to start with a phenomenon and try and explain it in different ways and come up and see that other methods fail, and then come up with a model, an explanation, a theory, and show that it fits the data, and then make predictions. And the prediction would be a phenomenon known as a black hole. And then you would go and search and you would see, yeah, we have found black holes in the universe. That's fine. But you're not going through all these steps. So you're not doing real science. Doing half of this is not science. It's half of science. It's not science. Science is the whole thing. With general relativity, you can do the whole thing. You don't need math for that. You can do it just like I'm doing, just with intuition. At least some of what I'm doing, but I wouldn't say I'm doing real science. I'm not gonna claim that I'm doing real science. I would say I'm trying to do science. I don't know what is real science. Why would you even use these words? So obnoxious. It's like everyone else is not real science. Everyone is fake science. Only Veritasium, he is real science. Why? Because he spake with the gods. The gods, they came to him and they spake to him. And now he is the prophet and he's giving us his knowledge. This is why I hate these people so much. This is so evil. This is just like the priesthood from the old days, the dark ages. The scientific clergy has become a copy of the church. Terrible. Absolutely terrible. Absolutely terrible behavior. And then people ask me, why do I hate these elites with the 15.8 million followers? Why do I hate them? Because these elites behave like clergy, like priesthood, like prophets of a religion, like a cult. Why do you talk this way? Why are you so arrogant towards everyone else? Absolutely disgusting, despicable, atrocious.
It also implies
And so much nonsense. So much nonsense. At least if you would make sense, if you would sit and slowly derive general relativity and then, derive. But you're not. You have these consultants. Einstein didn't have consultants. Einstein derived everything by himself. Okay, he was taught, but once you're taught, you're able to derive everything yourself. Otherwise, that's not science. That's nonsense.
the existence of parallel universes and even possibly a way to
And this is not even science because I'm not gonna say. I was gonna say because this you can never test it, but that's not true. It's not true. I think it is testable, but I don't think. Yeah, I think it might not be testable. It might not be science because of that.
travel between them. This is a video about the real science of black holes,
The real science. Jesus help me.
white holes, and wormholes.
And wormholes. Yeah, I don't know anything about that. I used to think that when a black hole forms, so from the inside, you experience a white hole. You experience a big bang, which is a white hole. And the black hole is therefore connected for an instant to this white hole. And the white hole disappears as soon as it goes off. But I don't know if that's true. I've since stopped thinking this way.
Holes. The general theory of relativity arose at least in part due to a fundamental flaw in Newtonian gravity. In the 1600s, Isaac Newton contemplated how an apple falls to the ground, how the moon orbits the Earth and Earth orbits the sun, and he concluded that every object with mass must attract every other. But Newton was troubled by his own theory. How could masses separated by such vast distances apply a
It wasn't really a theory. Newton didn't really have a theory of gravity. He just deduced the equations that describe gravity. He didn't have a theory how gravity arises. He didn't have a model of gravity. So I wouldn't say it's a theory. Did you say it's a theory?
by his own theory?
No.
How could masses separated? And he concluded that every object with mass must attract every other.
That's not a theory. Is it? Is it a simplified, simple model of reality? Is it? It might be a theory. You might say, I have a theory, and that what? That there is an equation? Why is it that equation? The equation has to come out of a model. His equation of gravity didn't come out of a model. Where's the equation? He showed the equation.
And wormholes. The general theory of relativity arose at least in part due to a fundamental.
This equation is empirically deduced. It's deduced empirically from the motions of the planets. This is the there's no model. He didn't. This is not. This doesn't come out of a model. A model of reality. Newton, when he heard about the motion of the planets, he heard about Copernicus. Copernicus had, I think it was Copernicus, wasn't Copernicus or the Polish guy? Copernicus is not the Polish guy. What's the name of the Polish whatever? So the Polish astronomer, the student of Tycho Brahe, or the helper. So anyway, I don't want to get into that. So I wouldn't say that that Newton had a theory. I don't. Did Newton claim that this is a theory? Did he even know the term? Did they have the term theory in those days? Would you say it's a theory of gravity? I don't. I think Newton just said it's a law of gravity. He didn't say it's a theory. What is the theory? What is the theory? Why would two objects have this relationship? Why? What's driving this? There's no theory behind it. M1 times M2 divided by R squared times G. That's the force. Why? What's the theory? I don't think there's a theory. So why are you calling it a theory? Why are you so loose with your terminology? Why are you so loose with your terminology, man?
Falls to the ground, how the moon orbits the Earth and Earth orbits the sun, and he concluded that every object with mass must attract every other. But Newton was troubled by his own theory. How could masses separated by such vast distances apply a force on each other?
What do you mean vast distances? How does an apple fall to the ground? That's not even a vast distance. How does that work? How do objects attract each other? Period. That's the question. For that, you need a theory. If you assume that there is a vacuum, assuming a vacuum, I think if you don't assume a vacuum, anyway, we're gonna get to it. 1 second.
He wrote that one body may act upon another at a distance through a
Let me see if there's anyone joining us. No, no one has joined us. Okay.
vacuum without the mediation of anything else is to me so great an absurdity that I believe no man who has a competent faculty of thinking could ever fall into it.
Yeah, that's good. So he admits that he doesn't have a theory, right?
He wrote that one body may act upon another at a distance through a vacuum without the mediation
Right, a vacuum. So he assumed that gravity works through a vacuum
of anything else is
without the mediation of anything else. So general relativity, if it's a theory, it has to assume that there is no vacuum. If you claim that still there is a vacuum, you end up with the same problem.
is to me so great an absurdity that I believe no man who has a competent faculty of thinking could ever fall into.
So all he said is, if you think that force can be mediated over a vacuum, that's nonsense. Anyway, he didn't have a theory. So did Einstein have a theory? We'll see.
Into it.
Let me check the audio. Where is the audio? It's pretty good. The audio is pretty good. I'm satisfied with the audio. I'm not going to finish this video. I just want to. My point covering this Veritasium is just to show the issues that I see in this video. I mean, there's many issues. If I did the whole video, there's many issues, many more issues. But you can tell there's many issues. You don't need at this point. You can tell that there's many. I don't want to say it's a terrible video. I don't want to judge Veritasium. I'm sure he works hard and tries, to. I'm sure he has good intentions. He wants the masses to know science. Yeah, that's his intention. But I think the way he goes about it is terrible. He's not teaching science. He's just teaching the conclusions, which is he's not teaching science. He's not. You don't teach science. Science is you have to do the science with everyone together. You have to debate science. You have to debate, and he never does live shows. So I mean, he needs to debate, but I don't think he's able to debate. I don't think that he understands everything he says. He's more like a speaker. He is a science communicator. He's not a scientist. So how could you say this is the real science if you're just a science communicator? You have a PhD in education of science education, which is terrific, but you're not a scientist unless you do education, science education. Then in that field, maybe you're a scientist. Maybe maybe you've done actual science in that field. But this is not that. This is general relativity. It's different. So anyway.
One man who definitely had a competent faculty of thinking was Albert Einstein.
Why would you say that? Why would you say who definitely had a faculty of thinking? Why are you judging people? Why are you talking this way?
And over 200 years later, he figured out how gravity is mediated.
I don't know why you say that. I don't know why you say that. What do you mean he figured it out? I don't know what you mean. We still don't know. I don't know, and I think about this a lot, and I've heard Einstein, and I heard everyone, and I still don't know how gravity is mediated. So I don't know why you say that.
Bodies do not exert.
I mean, I don't think Einstein has a model of gravity. It's, I mean, a little bit. He has an incomplete. I would say an incomplete model of gravity. Okay, let's continue.
Forces on each other directly is mediated. Bodies do not exert forces on each other directly.
Right, because that would be like if they were tethered to each other. Then yeah, that's fantastic. Another way, there is no other way the two bodies can attract each other than a tether, a rope.
Instead, a mass like the sun curves the space-time in its immediate vicinity.
That doesn't help. No, that's nonsense. That does not help. This idea of curvature, I thought about this. It doesn't. Curvature doesn't do anything.
This then curves the space-time around it, and so on all the way to the Earth. So the Earth orbits space-time around the space-time in each other directly. Instead, a mass like the sun curves the space-time in its immediate vicinity. This then curves the space-time around it, and so on all the way to the Earth. So the
Okay, so you have a theory that it's possible to curve space-time, whatever that is. I don't even know why they say space-time. Why not just say space? You curve space. It's difficult enough to imagine the curving of space. So you curve space. How does curving this, what does it even mean to curve space? I don't understand what it means to curve space. And how does that create gravity?
Earth orbits the sun because the space-time Earth is passing through is curved. Massive.
That doesn't make any sense. But what does that mean? I don't understand what that means. I don't understand. I don't know what you mean. I don't know what you mean.
Are affected by the local curvature of spacetime, so no action at a distance is required. Mathematically, this is described by Einstein's field equations. Can you write down the
Why do you go to mathematics? All you need to do is you can just say it's a field, just like the electrostatic field, like the magnetic field, like any field. You can imagine a field, a three-dimensional field. So you have a three-dimensional field. It's called space or space-time. It doesn't matter what you call it. It's a field. I would even say that it's 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 some foam. It's some media. It's something. It's not a vacuum. When you say there is a field, it's no longer a vacuum. So Einstein says there is no vacuum. There is something that mediates this thing that we call gravity. Namely, that if there's a mass, let's say the sun, so the sun, so you say it curves this foam. I wouldn't say it curves the foam. I would say it sucks in the foam, or we can even say water. So we can imagine that we're deep, that the universe is just it's filled with water. And that the sun is a water sink. It sucks in water all the time. Water is flowing into the sun. So, as you get closer to the sun, the flux is greater because the volume that is the sun is smaller than a volume as you move away from the sun. So as you move away from the sun, that volume through which there is a flux of water towards the sun, at any point the flux grows weaker and weaker. That's the way I would describe it. So now the earth, as the earth is moving through a straight line, the earth is moving through the water, but the water is moving towards the sun. So the earth is moving in the water like a submarine in a straight line. But the water is moving towards the sun. Let's say the earth is at a certain orbit around the sun. And at that orbit you can imagine a sphere, a hypothetical sphere. So that sphere has water flowing through it towards the sun. So as the earth submarine goes in a straight line tangent to this sphere, there's water flowing towards the center of the sphere. And that is what is causing Earth to go around the sun. And there is actual material that is pulled towards the sun. And whatever that is, that we call that space-time. But it's not a vacuum. If it were a vacuum, by definition, it wouldn't impose any force on Earth. In order to impose a force on Earth, there has to be something there. So this space-time flows towards the sun, and that's how we get the 1 over r squared law. 1 over r squared is just, I think it's from the geometry that I just described. At the surface of the sun, the flux is much greater than as you move further and further away. The surface of the sphere. Anyway, that's my theory. I never heard, I've only heard hints of other people thinking this way. But this is based on the very thought experiment that Einstein conducted to develop general relativity. So the bending, this comes out of the bending of the light. The light we know must bend under acceleration, hence it must bend under gravity. And the only way it can bend is if space-time flows just like it does when we accelerate. So this space-time must be stationary, and anyway, so we can develop, we can show, we can prove this from first principles. Everything I said must be true as far as I understand. This is this is this follows directly from the thought experiment of falling while being in a falling elevator while shooting a light beam and so on. This is directly from there. From that we know there must be a flowing foam of space through which everything moves. That everything is embedded in. I don't want to say we move through it. We don't move through it. This space is stationary relative to every inertial observer. That's why there's no damping effect, there's no friction effect, because the Earth is not moving through space. Space is stationary relative to Earth as an inertial frame of reference. All right, let's continue.
Einstein field equation.
So he's going to describe now the field equations, but I already described the field and the behavior of the field. So we don't need the equations. All we need to know is that a source is that source of or mass. Mass is a space sink. Space flows into mass. That comes out of the equivalence principle. That must be true if the equivalence principle is true. So space flows into gravitational sinks. That's it. That's Einstein's field equation. You don't even need to say there is an equation. All you need to understand is that this must be true. I need to show you how it comes out of the equivalence principle. But this will wait for another time. Let's see, how long have we been going? I don't want to go too long because the reason I'm recording this is more for the record than for people to listen to. I don't think a normal person can listen to this. Maybe someone who is deep into GR can enjoy this and agree with this, and maybe a lot of people might think this is trivial. I didn't say anything new. I would agree. Like, I think most of what I'm saying is trivial. Anyway, so I think let's go a little bit further, and then we'll call it quits.
This was the result of Einstein's decade of hard work after special relativity.
Okay, whatever.
And essentially what we've got in the field equation.
Okay, so this is Geraint F. Lewis, professor of astrophysics, the University of Sydney. Professor of astrophysics, like he teaches GR.
Equations. On one side, it says, tell me about the distribution of matter and energy. The other
Tell me about the distribution of matter of energy. Okay. So this is matter and energy.
side tells you what the resultant curvature of space-time.
This is the curvature of space-time. There's two terms.
Is from that distribution of matter and energy. And
okay.
It's a single line. It looks like, oh, this is a simple equation, right? But it's not really one equation. It's a family of equations.
I don't know what these terms mean. But why do I need to know more than the equivalence principle and the fact that space flows towards gravity wells? And this flow, I don't like curvature. The notion of curvature, I don't like that word. I prefer flow. Flow explains everything. Curvature doesn't explain anything. And all I need is just to understand that. I mean, this is maybe a numeric explanation of what I'm thinking. The question is, can I derive the equations from my thought experiment? I don't know.
And to make life more difficult.
Anyway, this is not science. I mean, just giving us the answers, obviously, that's not science.
They are coupled equations, so they depend upon each other, and they are differential equations. So it means that there are integrals that have to be done, da da da. So there's a whole.
No, you don't have to do anything. You can run simulations. Why would you even say that? Why would you? You don't have to do anything. You feed these equations into a simulation, just like I explained, right? I just told you that every mass is a gravity sink, and everything, there's water everywhere. The universe is filled with water, but it's frictionless water. That's the trick. It's frictionless water. This water is stationary relative to every inertial observer. Okay, and that's it. That's all you need to know. Now write a computer simulation and you get GR. What else do you want? You would see light curving. GR, you would see light curving, you would see Newtonian of course Newtonian gravity comes out of this model, but also light curves, because light travels through space. So, but it just travels very fast. Since it travels very fast, what is the speed of this flow? So the speed of the flow depends on how close you are to the sun, to the source, to the mass. But it's slower and slower as you are further and further away. So the speed of the flow away from any mass is basically zero. So light travels in straight lines when there's no mass in the region. But close to the sun, the flow is fast. So light would bend, because light travels, let's say, like basically like Earth. You could imagine light just like Earth traveling, instead of very slow like Earth, it just travels super fast. Because it travels so fast, it curves much less, right? If my speed is 300 whatever, what is 300,000 meters per second as I zoom by. And as I zoom by, the flow, you can imagine the flow of the water. Well, there's some speed. The flow of the water has a certain speed. The question is, why? Oh, and you see that the Earth, let's see, if there is another object that weighs less, that is at the same orbit as the Earth, would it have, would it be at the same orbit at the same speed? Or does, I'm wondering if we can see that the orbit is independent. Yeah, I think the orbit is independent of the mass, which means yeah. Anyway, so light, so Earth moves in a straight line, and it doesn't matter, the mass of the Earth doesn't matter, I think. Earth moves in a straight line as the water flows and bends its path. Okay, and what about light? Well, light travels very fast. Obviously, right? If we accelerated Earth, it would spiral out of the solar system. Now imagine Earth coming in super fast. Imagine Oumuamua coming into the solar system super fast. It barely curved. It didn't it didn't curve, even though it passed very close to the sun, closer than Earth, but it didn't get stuck in an orbit around the sun because it's traveling very fast. The faster you travel, the the less of an orbit you have, the less of an impact the sun has, or the water. It's not the sun, it's the water, right? Because if you say it's the sun, then you're saying that it's action at spooky action at a distance, like Newton complained. Then the vacuum influences you at a distance. You don't want to say that. You want to say that space flows. Because space flows, then you don't have the problem of mediating over a vacuum. Now you're not even mediating, rather there is a media, and everything moves in a straight line in the media, but the media is moving. That explains everything. That's an explanation. That's a model. That's a theory. But I don't think even Einstein thought of general relativity like this. Even Einstein, I don't think Einstein I would describe GR as a theory of gravity. What I'm describing is a theory of gravity. Uh, okay. Let's continue. Wait, where are we? Yeah, we can continue.
A bunch of steps that you need to do to solve the field equations.
That's not true. Not true. You don't need to solve equations. You can feed your data into the equations step by step and run a simulation. You don't need to solve equations. This is what people used to do in the past. You don't need to do that anymore.
To see what a solution to these equations would look like, we need a tool.
A solution just means a simulation. So now you want to run a simulation. So you can put the sun and the earth and run a simulation and see how, due to these equations, the earth goes into an orbit around the sun. That's what you want to show. That's what you want to show. Without using Newtonian mechanics, Newtonian gravity. So you use the field equations, the differential equations. The differential equations, you instead of using d, you use delta. And every delta, you actually feed in actual dimensions. You don't treat it as an infinitesimal length, but rather you actually take distances. You say, okay, let's cut up space into, let's say, kilometers, and let's feed that into a computer simulation. And you can even use the graphics. I think there is even graphics cards that do this. And if not, you can write a program for a graphics card, and you can, yeah, it should be fairly straightforward, and you can run a nice simulation of GR. And I assume people have done this, and this is available online, and you can probably search Google and see it. You don't need to see solutions. You have to explain whatever you want to simulate. Tell me what you want to simulate. I'll simulate. You don't need solution. You don't have to scare people with math.
To understand space-time.
What?
What a solution.
There's a whole bunch of steps that you need to do to solve the field equations.
To see what a solution to these equations would look like, we need
It's like, if it's like he's telling us something to. He's gonna pull down the information from the gods. Hold on, let me get the information from the gods.
a tool to understand space-time.
Why do you need a tool to understand space-time? I gave you everything you need.
So imagine you're floating around in empty space.
No, that's already not GR. That's not general relativity. You have to start from the equivalence principle. What are you doing now? I don't even know what he's doing now.
A flash of light goes off above your head and spreads out in all directions.
How is this relevant to our discussion? I don't even know where he's going with this now.
Now, your entire future, anything that can and will ever happen to you,
Why is this important? Why are you going there? What are you talking about? How is this relevant to GR? General relativity is a theory of gravity. Just throw in a bunch of objects and show us how you get Newtonian gravitational mechanics out of GR. That's all you need. Why do you need anything else? What are you doing? I don't know what is this guy doing?
to you will occur within this bubble, because the only way to get out of it would be to travel faster than light. In 2 dimensions, this bubble is just a growing circle. If we allow time to run up the screen and take snapshots at regular intervals,
How is this GR?
then this light bubble traces out a cone, your future light cone. By convention, the axes are scaled so that light rays always travel at 45 degrees. This cone reveals the only region of spacetime that you can ever hope to explore and influence. Now imagine that instead of a flash of light above your head, those photons were actually traveling in from all corners of the universe, and they met at that instant and then continued traveling on in their separate directions. Well, in that case, then into the past, these photons also reveal a light cone.
Why are we discussing time? Why are we discussing time? I don't understand.
Your past light cone. Only events that happened inside this cone could have affected you up to the present moment. We can simplify this diagram even further by plotting just one spatial and one time dimension. This is the space-time diagram of empty space. If you want to measure how far apart 2 events are in space-time, you use something called the space-time interval. The interval squared is equal to minus dt squared plus dx squared. Since space-time is flat,
You expect normal people to understand what you're talking about? At least if you would use delta. So why are you mentioning all of this?
the geometry is the same everywhere, and so this formula holds throughout the entire diagram, which makes it really easy to measure the separation between any 2 events.
Makes it easy to measure separation between. What are you talking about?
But around a mass, spacetime is curved, and therefore you need to modify the equation.
Okay, but that is what you want to show. That is the field equation. The curvature is the field equation. So in order, you said in order to understand the field equations, you need a tool. What are you talking about? What, so confusing. It's like, what are you doing?
Equation to take into account the geometry. This is what solutions to Einstein's equations are like.
What? Solutions to Einstein's equations are just, the solar system. The Earth or an apple falling towards Earth is a solution. What do you mean? The solution is gravity. Gravity is the solution. What are you talking about? It's just a solution with the flow of space. You can, but you need to show that this explains. One second, do I have an important message? You need to show that this explains our reality, right? We started with Newton. Newton was unhappy. Professional. That's not important. You started with Newton. You said Newton was unhappy with his not theory. And then came Einstein, and Einstein said, "Okay, I have a better idea. So here is my idea." And the way I'm interpreting, so Einstein wrote down the field equations. The field equations, you can model the universe as water. Space, let's say, is water. And the sun sucks in water. Or every mass sucks in the water. And the earth moves in a straight line. But because the water is being sucked towards the sun, so it's basically as if the sun is tugging at earth. That's it. That's the field. That is the field equation. That's it. That's the field, right? Where is the field? You said field. You keep saying field equations. So with me, you see the field. The field is the water. It's a water field or the space field, and the space is moving. It's a field that is moving. You can describe this motion with vectors. I don't want to get into math, but 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 anyway, so I don't know what this guy's talking about. He's At this point, I'm worrying that he's just trying to confuse the audience because he's lazy or he's confused. Who teaches this way? You took this, you showed this to any teacher. Any teacher saw this and said, "Wow, great lesson." I have no idea what you're talking about. I'm not a dummy dum dum when it comes to the field equations, to the theory. I don't even want to say the field equations. The theory, the field, the gr, the predictive, the field that is predicted by general relativity. The behavior of this field. I don't know what you're talking about. And the title is "Something Strange Happens When You Follow Einstein's Math." It's not Einstein's math. You mean Einstein's field equations? Okay, but why do you want to follow his field equations? You didn't derive them. What's the point? What is the point of this video?
They tell you how space-time curves and how to measure the separation.
This is like either for super geniuses that I'm not one of you, or this is just to make people feel. This is pretend science. This is the last thing I would call this is real science. This is pretend science. What is this?
To take into account the geometry. This is what solutions to Einstein's equations are like. They tell you how space-time curves and how to measure the separation between two events in that curve.
What do you mean separation? It just tells you how things move. It explains gravity. It explains that phenomenon that we call gravity. That's what you said. You said Newton was unhappy. He didn't have an explanation. GR comes to explain whether we like it. I don't know if Einstein intended it to, but it ended up explaining gravity. So What are you talking about with measuring distances? What are you talking about?
how space-time curves and
No, how space moves. I don't know why you say curves. The curvature doesn't help you. It doesn't explain anything. This notion of curvature does not explain. I don't like it. I don't like it. I like the motion. There is a flux. There is a flow of water, of space into massive objects. That explains everything. That's it. It explains why light bends, even though it doesn't have any mass. And it explains why any object at the speed of the Earth moves exactly as Earth moves. It's because of the speed of the Earth. It's not about the mass of the Earth. Any object that has this that has the speed of the Earth that would travel just as Earth is in that straight path would end up trapped in the orbit of Earth, and that's it.
how to measure the separation between two events in that curved geometry.
What are you talking about? I don't know what you're talking about. And you promised an explanation. You said Newton. What happened to Newton? Newton was unhappy. Can you explain why now we are happy? How we have a theory of gravity? Can you explain that?
Einstein published his equations in 1915 during the First World War, but he couldn't find an exact solution. Luckily, a copy of his paper made its way to the Eastern Front.
What do you mean he couldn't find exact? Didn't he immediately test it on Mercury and saw that he's getting the correct result? Because nobody could figure out, because according to Newton, Newton was predicting the wrong orbit of Mercury, and the first thing Einstein did is he tested it on Mercury, and he saw that he's getting the correct orbit. So why are you saying he couldn't get an exact solution? Why are you saying that?
Where Germany was fighting Russia. Stationed there was one of the best astrophysicists of the time, Karl Schwarzschild. Despite being
Why don't you tell us about his childhood if you're going to tell us so much?
41 years old, he had volunteered to calculate artillery trajectories for the German army. At least until a greater challenge caught his attention: how to solve Einstein's field equations. Schwarzschild did the standard physicist thing and imagined the simplest possible scenario: an eternal static universe with nothing in it except a single spherically symmetric point mass.
So notice he's saying point mass. I don't know if this is true, but if we assume it's a point mass, meaning it's a dimensionless mass.
Mass was electrically neutral and not rotating. Since this was the only feature of his universe, he measured everything using spherical coordinates relative to the center of this mass. So r is the radius.
Okay, I don't know. You just said it's a point mass. What do you mean center of this mass? You just said it's a point mass. What do you mean center of the mass? How do you have a center of a point? You see what I mean? This guy, how could you say something so terribly wrong? This is first grade. You learn the basic stuff. What is the point and what is the... And you're saying it's a point mass that has a center? Are you? What is wrong with you? This is real science. Yeah, yeah. What I'm doing, it's terrible. It's cacapoopoo. I'm doing fake science. What Mr. Veritasium is doing, it's real. How do we know it's real science? Well, he has 15.6 million subscribers. That's real science. Everybody knows real science is a big channel. That's real science because he said so. And he has the following, so everybody hears him. So he is real science. If you're a descending voice, no one's going to hear you. No one has a bullhorn the size that he has. So he has the real science. He wins this war.
Radius and theta and phi give the angles. For his time electrically neutral and imagined the simplest possible scenario, an eternal.
By the way, notice that here. Okay. He has just a mustache. That's fine.
Schwarzschild did the standard physicist thing and imagined the simplest possible scenario, an eternal static universe with nothing in it except a single spherically symmetric point mass. This mass was electrically neutral and not rotating. Since this was the only feature of his universe, he measured everything using spherical coordinates relative to the center of this mass. So
Center of this mass. Unbelievable.
r is the radius, and theta and phi give the angles. For his time coordinate, he chose time as being measured by someone far away from the mass, where spacetime is essentially flat. Using this approach, Schwarzschild found the first non-trivial solution to Einstein's equations.
Let's see if we can figure it out. We set c equal to 1. Speed of light is 1 and g equals 1. That's at the bottom here. And rs equals 2m. The radius of something, I don't know what, equals 2m. I don't know. So, this is a differential equation. This is not, he calls this the solution? This is the solution? Mm, I don't, okay, whatever.
Which nowadays we write like this. This Schwarzschild metric describes how spacetime curves outside of the mass.
Okay. Okay, so we expect, I mean, you're telling us about the curvature, that's just a metric, but you want to actually predict, right? So the way I would do it, I would create the sun as a point mass and the earth. I don't even need to create the earth as a point mass because GR doesn't need the earth to have a mass. All the earth needs to have is a speed. That speed, it will be diverted by the flow of space. But I think we need to go. What time is it? Yeah, we've been here for a long time. Anything
It's pretty
critical?
simple and makes intuitive sense. Far away from the mass, spacetime
Intuitive sense. That's good because there's also sense that is not intuitive. Yeah.
is nearly flat, but as you get closer and closer to it, spacetime becomes more and more curved, it attracts objects in, and time runs slower.
It attracts objects in and time runs slow. Right. One of the effects of GRs besides, so GR, because it affects light. So once it affects light, it because it affects light, it slows down time. I have to think about it, but I'm too tired. All right, let's stop here. I don't know if I'll continue. I just wanted to give a critique of a little bit, not even of. I have much more to say about black holes, obviously, but I'm criticizing not even the methodology, but the pedagogology, whatever, the way he's teaching, the way Veritasium is teaching, he's not teaching. I'm not learning anything from Mr. Veritasium. I don't think anyone is supposed to have learned anything from this video. I think he's like trying to make us feel good that we're learning science and we're sciencey, and the public, it's like he's treating, this is like a sermon. This is like a religious sermon. This is like a cult sermon that the prophet comes from the gods and tells the public, you don't have access to the knowledge of the gods, therefore I, the prophet, I, the clergy, I will give you the answers. And the answer is, and so and so. He just gives answers. He just tells us the result. He doesn't do the investigation. He doesn't go through the steps. He skips over mm, almost everything. Almost nothing makes any sense. And part of it is look at how much general relativity makes no sense. That's like part of it. Look at how crazy everything is, right? And that's the name of the video. Something strange happens. This is like magic. This is like anti science. Something strange happens. Look at how science is not science. Look at how science is not intuitive. This is just terrible. This is nothing. This is not science. This is nothing. This is a religion. This is a cult. Terrible. Absolutely terrible. Yeah. Okay, I'm gonna stop here. Thank you everyone for listening thus far. I hope you enjoyed it, and if not, one day someone will listen and maybe will appreciate it. Hopefully, I just wanted. There's a lot of stuff I want to say, but I didn't get to say almost anything. I was bogged down with criticizing Veritasium more than anything. Okay, everyone. But you know what happened? I'm happy is that I came up with the water model, the flow model. I came to incredible revelations and realizations. So it was totally worth it. For me, it was worth it. So I guess anyone watching this, so you saw me going through the process. You saw me doing what I would say is, I don't know what he means by science, but you saw how slowly and meticulously and carefully I'm going through these thought experiments. So I think there's a lot to be learned from my methodology, from my investigation, my research. I think. You tell me. You be the audience. All right, everyone. Thank you very much. And that's it. I'll see you next time. Bye bye.